In Part 3 of Lecture 6, we will discuss network nodes, topologies, and protocols. The temptation when planning a network might be to have every node connect directly to every other node, but that requires a lot of connections. Let's say we have n nodes. They would have to be connected to n-1 other nodes. That gives us n times n-1. But that means that we have node A connected to node B and node B to node A. We need to divide by 2. When we only have 10 nodes, that means we need 45 connections. If it's 100 nodes, our connections grow to 4,950. If it's 1,000 nodes, we need almost 500,000 connections. And the connections keep growing much faster than the number of nodes. So we can see that it will pay to have most of these connections through intermediate nodes. A topology is defined as the way in which constituent parts are interrelated or arranged. In our case, we don't mean it quite so literally. We think of it as defining the logical relationship between nodes on a network. A network topology refers to the structures and layout of network components. The point-to-point topology deals with connecting two computers with a connection. It is too insignificant to consider at this point. We are going to look specifically at 3 topologies. Star topology has all the devices connecting through a single central node. A mesh topology has a collection of nodes that are heavily interconnected to each other. A full mesh would have every node connected to every other node, but a partial mesh doesn't need to be so completely interconnected. The bus topology has all the devices connected to a common wire in a linear arrangement. This is used most frequently in local area networks. These slides show their relative advantages and disadvantages. Star networks only have one vulnerable point, the center. Any other node being out of service lets the remainder of the network continue as before. While mesh networks have multiple failure points, having redundant paths allows the rest of the network to continue to work. Star networks are more secure because there are only 3 nodes that would have contact with the message. Only these 3 would be vulnerable. But given the larger number of nodes through which the message needs to traverse, the risk of infection is greater. Star topologies have a real limit in their capacity. They cannot handle more data than the central node can. The limit for a mesh network will be higher because not all communications go through the same nodes. Expansion is limited in a star network by the number of devices that are connected to the center. There are no such restrictions on mesh networks. Control is easier to maintain because the center is 1 node away from everything in a star network. But setup and control is more complex in a mesh network given that there is no central point. With everything going through the center point, it is easier to monitor what's going on. In a mesh network without this center, it is more difficult to monitor what is going on. All the devices on the network are called nodes. The word indicates an intersecting point, and that is an accurate description of what a node is all about. This is where some or all of the wiring converges. What we find is that there are 2 kinds of nodes on a computer network, DTEs and DCEs. DTE stands for Data Terminal Equipment. This is the end of the line for our data. Data either originates here or terminates here. DCE stands for Data Communication Equipment. The network exists so that the DTE can send and receive data. The DCE exists to enable this communication to happen. There are two pieces of data communications equipment that we need to talk about. A router is a device that controls the flow of data within the network. It also acts as a gateway of sorts for data that is passing from one network into the other. The assumption is that while the data networks are not necessarily the same, they have to be fairly similar. A modem, which is short for modulator-demodulator, contains circuitry that will take the data signals coming from our computer and translate them into signals that can travel vast distances over communication channels. On the other end, they then convert it back to a form that makes sense to the computer. There are different types of data communications equipment. One thing they all have in common is that they pass on the data that they receive. A hub connects multiple devices together and makes them act as a single network segment. It has multiple input-output ports, which allows the network to include more devices. A bridge is a device that connects network devices together using packet switching to receive, process, and forward data to its destination. Its signals go to individual nodes rather than broadcasting them to the entire network. A bridge creates a single network from more than one network. It is assumed that the networks being bridged are similar. A repeater extends the range of a network by receiving a signal and repeating it at maximum strength. A wireless access point gives wireless access to a wired network. They are known less formally as hotspots. There are always rules that govern communication, although many times we are not conscious of our following these rules. Eye contact establishes that we are paying attention. An occasional uh-huh or I see is said to acknowledge that we understand what was said. We adapt to the pace at which someone else is speaking, and we adapt when someone is speaking with a different accent. These are done subconsciously and in part because people can adapt easily. But digital communications equipment is nowhere near as adaptable. That's why communications protocols exist and are used, establishing many of the rules under which a communication session will function. Establishing these rules and recognizing the protocols in use is called handshaking. You should keep in mind that there is not just one protocol in use. Networks actually use a collection of protocols, depending on the level of complexity on which they are working at a given point in time. This collection is called a protocol stack. If you have ever played the game telephone, you know that it isn't always easy to repeat what someone else says accurately. This is actually what makes the game fun. But in computer communications, it's not so funny. For this reason, networks need a set of standards that allow them to notice when there is an error in communications. We refer to this as error detection. If we can actually fix that, it is error correction.